Thank you very much. So I'm here to tell a story that I've called the XE files. But first, I'm just going to say who I am. So I'm James Atack, or Atack if you prefer. I'm Deputy CTO at ONYPHE, which is an attack surface management company. It just happened like that, right? There was no design in this. Previously, I was head of CERT at a central bank. Before that, I was a security architect. I thought I wanted to be a pen tester. I changed my mind quite quickly and did something else. Before that, I was a sysadmin, and going right back, I started off on tech support, help desk, all that kind of stuff. So quite a mixed IT background. I'm not a data visualization genius, and the story today is trying to make some sense of about 500 million data points. So please bear with me. When there are crappy charts and graphs, you just have to deal with it, basically. I can't do any better. A brief word about ONYPHE. Because this talk is using ONYPHE data, so I'm sharing with you data that we've collected by scanning the internet. That's what ONYPHE does. We scan the internet, we identify stuff that's connected to the internet, URLs, and when we combine it with loads of other data like threat feeds, we have our own passive DNS, CTLs, and then we also identify critical vulnerabilities and risks. The map in the background is a heat map, just country by country, of where critical vulnerabilities are at the moment. So there's some interesting stuff in there. We do have a free tier, but you don't get access to that with a free tier. But create an account if you want to have a look. It's all available, REST APIs and that kind of stuff. So what's my alignment? I'm lawful neutral. I think if you work and you're doing some kind of like exploit on an internet scale, then you have to be at least on the middle line, right? My boss, Patrice, who founded ONYPHE, he's chaotic neutral, which I think kind of makes sense, given that he built this thing all by himself. So let's get into the story. So last year, on the 28th of September, a Cisco customer opened a support ticket with the Atack, the Technical Assistance Center. And we don't know for sure, but they were probably saying, why has somebody just created an admin account on my very expensive router with the name Cisco Tac admin? The activity, strange activity on that device, stopped as soon as Cisco support started poking around with it. And if the story stopped there, you know, it would just be another support ticket, device rebooted, all okay. But then 2 weeks later, Cisco Talos incident response, so Talos is the threat intelligence part of Cisco, if you've not come across them, they detected what they called a cluster of related activity. So they had observed the same threat actor tidying up, basically, deleting their Cisco TAC admin accounts and creating the entirely more plausible Cisco support accounts. They were also deploying an implant in these devices. And at this stage, Cisco had no idea how it was being done. They worked hard, and a few days later, it was a Monday morning, as the sun rose in California, Cisco put out a security bulletin. It was a CVSS 10 in Cisco iOS XE web UI feature, and it was 20 days under active exploitation, no patch available. The link to this, have I got, yeah, can you see the arrow? Yeah, cool. So, no, this is the link to the security bulletin. And the advice was basically, take your HTTP web interfaces off the internet. At the same time, Talos put out a blog post, which was really good. To their credit, they shared loads of information. They shared the source code of the implant that they found on the devices, and they shared, so this is the URL that they shared, where you could scan to identify if a device was impacted or not. What's interesting here is that they classified it as a privesc. I mean, basically, they had no idea someone was creating admin accounts, so they were like, it must be a privesk, right? I mean, sure. It's one way of looking at it. As they provided this information, it was only a matter of time before somebody started scanning the internet to find these infected devices. And indeed, on the Tuesday, it wasn't us, because we were traveling to a CTI conference in Luxembourg. It was a guy called Jacob Baines, who works for Vulncheck. That's his link. And he started scanning the internet using the information in this blog. About halfway through, he put out his blog post because he'd already found 10,000 compromised routers, and he'd only scanned half of the IPs that he was interested in. And so, cue cyber shitstorm, right? This is what happens. We, ONYPHE, scanned for the first time iOS XE compromised devices for compromised for the implant on the Wednesday morning, the following morning, the 18th of October. We scanned 80,000 devices that we thought were Cisco IOS XE, and we identified the implant on 53,000 of them. So you had 53,000 compromised Cisco devices. This is basically, we sent a post request to this URL with a couple of other headers, and if we got back a response that looked like this, then the machine was compromised. This is actually the web shell, the implant, responding to us. So this was not so much a cluster as another kind of cluster, a Charlie Foxtrot, if you're into NATO acronyms. As we're talking about Cisco IOS XE, and as you're probably not all network engineers, I thought we would have a mandatory training. I know mandatory training is going to send chills down some of your spines, but bear with me. I think one of the problems with cybersecurity is that, we like to think that we're experts on everything. So we're like, yeah, CVSS 10 in Cisco IOS XE. I know what that is. That's fine. It's a Cisco-y thing. It's like, it's got plugs and lights and stuff, right? But what is the difference between IOS XE and Cisco IOS that I've heard about for decades? Well, to sum it up, what they've done is taken 30 years of solid software engineering, the kind of software engineering that run the internet for the previous 20, 30 decades, 2 or 3 decades, and they've crammed it into a daemon service running on a Linux kernel. And because it's running on a standard Linux kernel, you get containers, you get KVM, you get VMs, you get pretty much anything you want. You want a Python API to control the iOS subsystem? Sure, you have a Python API. You want a web interface, and I quote, to simplify system deployment and manageability and to enhance the user experience, enabled by default. So, and just to show you how, what Cisco have been smoking, I took this straight off their website. Cisco IOS XE for an evolving network. It's for the future of work. Yeah, just not your work, somebody else's. Cisco IOS XE reduces business and network complexity. Possibly, yeah. Just, again, not for the people that they're thinking it does. Okay, I took this one straight off. I have no idea what this is showing, but it just screams attack surface, right? So this is your mandatory training on Cisco IOS XE. The final part, this is actually optional, but there's a YouTube video. This guy is running a Linux container with an XFCE desktop and Wireshark inside it on a Catalyst switch. So any pen testers out there, if you're stuck on an enterprise network, wondering what to do next, Cisco IOS XE is your friend. So that's the software side. What about the hardware? So So they started, so it first came out in 2016 on what they call ASR. So ASR, I've just got my notes because otherwise I'd not remember all this. Aggregation Services Router. So this is an ASR command module, or whatever they call it. The basic one of those with like no licenses or anything, that's like $50,000. Just so you get an idea of kind of, you know, what these things cost. This whole big stack here, that's, what is that? Like 13U or something. They have 64 gig of RAM. They're really big devices. So these are Cisco ASR routers. They're the kind of things you'd find in very large enterprises or in telcos. iOS XE was then also pushed out on these smaller boxes. These are ISRs, or integrated services routers, and that's the kind of thing that your telco would give you if you've got a leased line. I know I'm just like decades out of date, but whatever. If you get an internet connection from a telco and you're an enterprise, you'll get one of these things to plug into your firewall. There are ISRs. Special mention for these things, that's a converged broadband router. It doesn't quite look like your Freebox though, does it? This is the kind of thing you need if you want to provide broadband services to a town, small town. The backplane on this has got 1.5 terabit per second throughput. So what I'm trying to get across is that the hardware here is serious hardware. You know, this has got amazing redundancy capabilities. It's robust. It's the kind of stuff you put in data centers, and it's as you know, as redundant and as high performance as Cisco can make it. People just throw money at these things. It's also in switches, because these layer 3 switches, these are Catalyst Enterprise and Catalyst Workgroup switches. This is the kind of thing that Wireshark interface was running on. The market share, I'll explain how I got these numbers later. So if you go back to the 53,000 compromised routers, roughly 3/4 of them are ISRs, so these smaller ones. About 20%, just under 20% are these switches. And then you've got just under 6% are the big routers. And then there's some, you know, only 0.3% are the CBRs, but 0.3% out of 50,000. So, yeah, there's still lots of them. So let's get back to the story. Now you've had your mandatory network engineer training. You can all stick that on LinkedIn. Let's get back to the story. It's mid-October last year. 53,000 Cisco devices are compromised, but organizations are responding, right? They're taking them off the internet. They're pulling the web interfaces down. They can't patch them. There isn't a patch. Just remember it. But in any case, if we look here, we had like 80,000, and by the Friday, we're down to like 65,000. So the $170 billion cybersecurity industry has managed to get us down from 80,000 potentially compromised devices to 65,000 compromised devices. I mean, still 15,000 devices. It's not bad, right? But I asked myself the question, well, who were these companies? You know, who was good at getting the 15,000 devices off the internet really quickly? And so what I did was I took the data set of all the potential iOS XE devices before and the 16th of October 2023, and then compared it with what organizations still had Cisco devices on the, I think it was the 19th. And I've created the Unplugging Awards 2023, and so in the country category, they are the best. It was the 4th of July yesterday. Greetings to all the US citizens here. You are the best, and you removed 10,408 devices off the internet. But you've got to see it, the special mention for China, because although they only removed 5,274 devices off the internet, that was 91.4% reduction. I'm like, wow, they have really good processes. I mean, it's surprising, right? And it's especially surprising when you compare it to the Philippines, India, and Mexico. They're in the 20%. And indeed, and this is at the height of visibility and awareness of this issue. This is when it's in the newspapers or, on the cybersecurity websites and all of that stuff. You can go on Twitter, people are talking about it. And still only 23% reduction. And indeed, a lot of the devices now on the internet are in those countries. So I thought, well, let's break it down by organization. And this is where it starts getting a bit weird. I mean, at the top of the chart, you have 2 Chinese telcos who it turns out have incredible high-performance cyber defense processes where they can take down 97% of their potentially affected devices in just a few days. And they have much higher performance than Amazon. I mean, I have massive respect for the Amazon cyber teams, and they're at 80% or 82%. Microsoft 68%. That's kind of how I see Microsoft. Kind of okay, could do better, right? But all of these Chinese organizations are like in the high 90s. Huawei, 100%. Special gold medal for Huawei. So I'm not reading too much into this at this stage, but I'm like, okay, some organizations were very good at taking stuff off the internet, others not so much. Quick mention for organizations still plugging routers in. So Cisco, on the 18th, they had 10 devices. On the 19th, they had 12. They deployed 2 devices under the domain securitydemo.net. They were trying to, I think they were trying to get them compromised so they could get more threat intelligence. But on the 20th, they took them all offline. They were never compromised. So I think the threat actor was specifically avoiding them. What happened next? It all started to get a bit weird. So my boss texted me on the Saturday morning, and he's like, James, those 40,000 compromised routers from yesterday, they're all fixed now. And so, we talked about it. And there was really 2 scenarios. Either every network engineer on the planet had been given a cash bonus to get off their sofa and fix it, or the threat actor had changed something. And I don't know if you know any network engineers, but yeah, it was B. So we reached out. We put out a Twitter post, some other people looking at the same thing. We agreed with our conclusions. We talked about this. And by the Monday evening, the people at Fox IT, great organization, by the way, if you have an incident response need, quick plug for them, they'd pointed out that there was something in the original web implant that allowed you to detect even with the web implant patch. So what had happened is the threat actor had changed the implant so that you had to provide an authorization header to hit that API. And we didn't have that authorization header, but what we did have was, let me just go back. Here. There's this little location percent at the bottom. And if you hit a URL with a percent in it, you got a 404. So we all started doing that, and sure enough, we now got implant V2, and I call this slide asymmetric capabilities because it's kind of what I said before. You can see here the total number of devices that could be potentially compromised going down at the top, and the actual compromised devices going down here. You've got everybody responding to this on a cyber side, on the telco side. The threat actor just casually patches 40,000 devices overnight, right? They are much, much better than us. So that's, and I mean, you look at this, implant V1, 818, so they've got about a 3% failure rate, and as far as we can tell, no bricked devices. Right, so there's some good quality control. They've got some DevOps capabilities. It's a serious operation. During the weekend, Cisco did some quality testing as well. They finally got the patches out on that Sunday night. Obviously, I'm not comparing the capabilities of the $185 billion company, 85,000 employees, that is Cisco, with this threat actor. You know, these events happen to happen at the same time. And but yeah, I think Cisco could maybe learn from their adversary. Right. So by the Monday evening, sorry, I've just lost my notes. Okay, we've done all of that. Talking about quality control, this was not a fire and forget operation. So the threat actor has updated their devices. About 10 days after the start, a lot of these devices have been rebooted, and so the number of compromises going down because the web implant's not persistent. But then they did a new campaign to re-compromise a bunch of devices, and it jumps up again. So you can see that they're maintaining this network. It's not just a kind of, we'll just fire off a script and then wait and see what happens. And then sure enough, as you can see at the end here on the 3rd of November, another weird thing happens again. Implants updated again, and we can't detect anything. Right. The same thing was happening, so they pushed out an update. But it's a bit weird, and I mention this because the functional specifications don't make sense, right? What they did originally when they did their V2 implant is, if you hit any random URL on a Cisco IOS XE, you just make up a random URL, hit it, you get a 401 and a JavaScript redirect to the login page. What they had originally was a 404. If you hit that percent endpoint, you got a 404. So it was obvious that it was something different because nothing else responded 404. So they're like, okay, we need to change our implant so that when you hit this URL, you get redirected back to the login page. But there's like a gap between what they're trying to implement and what they actually implement. So they didn't implement a JavaScript redirect to the login page. They just send you the login page. So it's kind of interesting because it's kind of the behavior of like one of the companies that we work for, right? You've got the functional people that say it needs to go back to the login page, and the technical people go, okay, sure, that's what I'm going to implement. But it's not exactly what they want. They're kind of, there's a slight disconnect. And so we were still able to, even though we were getting these login pages, we could still detect them because we're not getting it via a JavaScript redirect. So now we've got the third iteration, implant V3. It's still kind of going down. There's still a kind of downward trend. What's also really obvious is the hole in our data set. Quick word about the hole in our data set. When we run these scans, we're trying to we want one of us to be monitoring what's going on. We take this seriously. We're connecting all these devices. Somebody has to be present, keeping an eye on it. And on that day, there was nobody. I was on holiday, and Patrice, my boss, lives on the coast in Finisterre. And if there are any journalists looking for a factually incorrect, sensationalist headline for this talk, then I've written you this one. But there we go. Right. So that's the hole in the data set. He had no electricity for 3 days, and yeah. What you can also see in this data is that you start getting these spikes. So what's going on here is that this is we do two types of scans. We do weekly scans, which are kind of for our enterprise customers. And each time we do a weekly scan, we go back to our original data set and say, give us every potential iOS XE device. And so that includes anybody who's deployed a new honeypot, then that'll be in this data. Whereas all the daily stuff between the spikes is the original list of IP addresses that we took on the 16th of October. So we can compare it over time, and we're comparing like for like over time. And you might be looking at this and feeling kind of positive. I mean, maybe if it went on for a couple of centuries, I don't know, maybe this would get down to 0. But, you know, you might think, well, 50% compromised at the end of the year is not too bad. But just to remind you, this is cybersecurity operations. You're not allowed to be positive. Happy New Year is, this is what happened at the start of the year. New year, new objectives, new budget, I don't know. But the threat actors suddenly woke up again and started recompromising a lot of the devices that had, you know, were potentially fixed, but in fact weren't. And I brought it, this data set stops here at the middle of February. That's when we stopped doing daily scans, just because it was taking up a bunch of storage space. We keep the full response, the full HTTP response from every one of these devices, and we had daily scans for like 5 months or something. So then this is weekly scans, but this is right up to Wednesday. And so as of Wednesday, you had 33,953 compromised devices out of 51,659. That's basically 2/3. So 2/3 of the Cisco IOS XE devices with their HTTP internet with their HTTP interface exposed are compromised. I mean, yeah. I tried to talk about this, right? I was like, this is really bad. I mean, even like early on, I was like, this is terrible. And so I would go on Twitter or whatever, and, you know, I would get no traction. But I was like, okay, well, I've only got a couple of hundred followers. Maybe, you know, nobody's just interested. The security research engineering tech lead at Cisco Talos back in January, when that you know, new wave of compromises happened, is like, you know, please stop opening the admin interface on the internet. It's like one like, you know. This poor guy, I mean, you can just see him like, you know, pleading with everybody. I mean, yeah. So it's terrible. In fact, it's even more terrible. So you might be like, oh, yeah, but at least these machines are okay, James. And I'm like, well, I talked to a couple of other CERTs, and Jérôme Orange CERT had been trying out a couple of things, and he was like, have you noticed that the implant makes the devices basically immune to the exploit for the vulnerability? So you can't exploit a machine that's already been compromised. Therefore, we added a vulnerability scan at the end of May. That means that all the machines that are not compromised are vulnerable. And if they're vulnerable, that means they're not compromised. So basically, and in fact, you can see this in the data. Like when the compromise goes down, the vulnerable goes up. So there's a tiny margin of like maybe less than 10% of the machines that are exposed their interface on the internet and are okay, but most of them are screwed one way or the other. And I think the threat actor likes it like this way, because they've got their 2/3 is like, that's my running population of devices, and the 11,745, that's my backup devices. If I need to fail over, you know, I've got 11,000 spare nodes. Okay. Just a bit about how we do this. So, so we scan the internet. We scan the IPv4 space, and we also crawl URLs. So when we hit a endpoint, a web endpoint, and we find a web page, you know, index.html or whatever, we're going to pass that page. Any URLs we find in the page, we're then going to visit those URLs, follow the redirects, identify more URLs, and we do that. So we're scanning about 300 million URLs a month, and with the open ports that we scan, we're storing about 1.2 billion service banners a month. And then out of that, we say, well, how can we fingerprint all of the potential iOS XE devices? So it's all of the potential URLs, the stuff that we can see in the header, and we come up with a list of devices. And then we have specific checks, and we run these specific checks. So it's Perl code. In ONYPHE, everything's running in Perl. It does the job really, really well. I think actually for our use case, it's the right choice of technology. But I'm not going to defend Perl more than that. You talk to Patrice if you want to know more. So yeah, we have these specific checks that only target the machines that are potentially Cisco IOS XE devices. We're not doing like, 0000/0 scans with these exploit code. We're just targeting the, whatever it is, 65,000 potential iOS XE devices on the internet. And then with each specific check, we then add tags. So this machine here has been tagged vulnerable because the exploit check has detected that that the exploit runs. And the background for my slide, I put it in slightly higher contrast so you can see it. The exploit check brings back, I sent a uname-a to all these devices, and it brings back the software stack and the model of the device, which is how I was able to get those statistics on what kind of hardware are we actually dealing with. If you want to see what data we store, that's all in this data model. And we have this 10 commandments for ethical internet scanning. Patrice did a talk at HackLu in Luxembourg in 2022. And so, yeah, we really take this seriously. We're not just doing this n'importe comment, as the French would say, where, it's as ethical as we can possibly make it. Let's just talk about who the threat actor is. So you've got an organization that's compromising these devices, and you might be like, well, it's, okay, if it's ransomware, then we're going to see ransomware incidents. If it's espionage, then they're going to try and compromise those machines. They're going to, be, I don't know, intercepting logins or whatever. They're going to be looking to move laterally within the organization. But in fact, in the first Talos threat advisory, they shared the list of commands that the attacker was running when they were doing reconnaissance. And what they're actually interested in is the devices themselves. The first thing they want to know is, who are my nearest neighbors? What are the routes to get to this machine? Then they're like, what are the services running on this machine? What's the power configuration? What's the system patch level? What's the power configuration? Am I providing, if I'm providing power over Ethernet services to other devices from this device, if I reboot it, what's the impact going to be? So all of these commands are trying to find out about the actual device itself, which is telling you what they want. They don't want your traffic. They don't want your data. They want your router. It's a distributed architecture. I couldn't actually get the data, the scale right. I wanted to zoom in an extra layer. These are clusters of compromised machines. But I have not found a country in the world that doesn't have one of these compromised routers. I don't know where this is, but it's in the middle of the Pacific. They have one. The Maldives, right? 4. One in New Zealand, and even in Greenland, they've got a compromised. I mean, this is the most distributed architecture possible. Like I say, you can zoom in at any level on this visualization, and every country has compromised devices. Let me just take this one here, 323. What is that? So that's Kenya, and you've got a Kenyan telco, and it's really obvious what it is. The Kenyan telco has got a subnet that's named telco customers. And then for every customer, they've deployed one of these ISR devices. And so the router is managed, in inverted commas, by the telco. And every customer has one, and they're running in their data center. But the customer doesn't really have access to it. The telco doesn't bother to patch it. And so you end up with 361 compromised Cisco routers. Okay. I thought, so that's the visualization. The US is still the top country in terms of number of compromised machines, but it's super distributed. So there's no one organization. So there's 355 at AT&T Internet, 441 at CableNet. There's no one organization that's was hosting these machines. It's in Mexico with Uninet that's got nearly 3,000, where one organization could do something and make a kind of significant dent in this number of machines. But it's what I wanted to show with this slide. Just with the top 3 countries, I took the top 10 organizations for the top 3 countries, and I don't get very far. It's the full list would be pages and pages. And what's interesting is that what's not in this list. So there are some devices, if you remember going back to this graph, right here there are still some devices, 287 running V2. And I was like, what are the 287 V2? Why is the threat actor not wanting to compromise those ones as well? Well, those ones, the highest in the US is Amazon. So they're basically, I think, it's my hypothesis, they're choosing not to compromise those machines because they're on Amazon's network. And what makes me think that is that Shadow Server, so who knows Shadow Server? Okay, so they're a UK government funded organization. They're independent, funded to try and understand background noise and threats on the internet. They deployed in March a bunch of routers with the implant V2 already already installed on them. Well, that's my hypothesis, because they just popped up in the data set in March in the UAE randomly, but they're on Shadow Server Foundation's subnet. And those machines have never been touched. They've never been compromised with the V3 implant. They've just been left alone. And I think the threat actor is showing again a level of sophistication in that they're deliberately not targeting these machines. Sure, some of them will be just, zombie machines that have crashed or whatever. But generally, they're targeting some machines and leaving other ones. So, who is our threat actor? We've identified persistent, motivated, and capable threat actor. What do I mean by persistent? So there's regular campaigns to update or compromise rebooted devices. Motivated, so they're undeterred by all of that intense focus of the cybersecurity community looking at what they were doing. And capable, I mean, they can patch 40,000 machines overnight. And so, that's the first point. This corporate behavior. So they're like agile. They're moving, they're doing deployments about every 10 days, but it's not overnight. It's not a cyber criminal, one guy in a bedroom doing this. This smells of meetings and processes. And then there's the whole thing about the functional specs not being exactly right, or the implementation not being exactly what they wanted, even though I'm sure if you stood up a router with an implant and one that didn't next to each other and you hit the URL, you get the same end result. But technically, they didn't manage to do what they were trying to do, which was blend into the background. And so then they've got clear technical objectives. That whole thing about, those list of commands, they want to understand the network, understand the hardware, maintain the number of compromised devices, and avoid being observed in operation. And my talk was going to stop there, and I was going to finish with, the truth is out there, because I had no other information. And then at the end of May, Mandiant put out a blog post. A guy called Michael Raggi put out a blog post. He works for Mandiant. And here's the link to it. And this blog post is on operational relay box networks, ORB networks. And I quoted a couple of sentences from here. So orb networks are infrastructure networks administered by independent entities, contractors or administrators within the People's Republic of China. And what do? Well, you've got their adversary. The adversary has a set of relay boxes. So these are actually often VPS, so little Linux servers stood up in cheap hosting companies. And then they route their traffic through the orb network. And so you have traversal nodes and then exit nodes, and then they hit their target. And I talked to friends who are in CERT teams who'd been targeted in espionage operations, and we've seen this from the other side. Espionage campaigns where every single request back to the C2 goes to a different IP address. Every time you're hit, it comes from a different IP address. And you can't, so that trying to make sense of your network logs is almost impossible. You're trying to trace the attack, but as every single thing the attacker's doing is coming from a different machine, it's almost impossible. I put the sentences as well. I just think it's really interesting. So one of the objectives of these contractors is to be able to rotate the infrastructure regularly so that they're not using the same IP addresses on a month-by-month basis. In that article, they talk about, they've got 3 networks. They mention Orb 1, Orb 2, Orb 3, and they specifically refer to Cisco routers in the Orb 2 network. So my hypothesis is that the infrastructure I've just been talking to you about, those, 35,000 compromised routers, makes up the backbone of the traversal nodes and exit nodes of this Orb 2 network. I actually reached out to Michael. He knows that I'm doing a talk, and hopefully he agrees with my conclusions. Because the behavior of the threat actor, their technical objectives, what we've observed them doing, match perfectly with requirements for running an orb network. And this orb network's been used by APT31, but according to Mandiant. But this is kind of the point, that these are service providers for threat actors. This orb network doesn't belong to APT31. It's used by APT31 on a sort of service basis, and there's some kind of private entity running this network, maintaining it, making sure that it's got enough nodes in it to meet their KPIs. This is a service agreement. So, I mean, it's kind of shocking. They've kind of taken, a Western IT services model, and they're now applying it to espionage at a large scale. What can we do about it? I put this in because I thought this was just super funny. It seems out that Cisco actually thought about this problem. You can actually solve the problem by getting a network cable like this and plugging it in, and then unplugging it out. If you do that once a week, you'll be fine, because that accidentally reboots the catalyst switch. The workaround, you know what the workaround is? Get a pair of scissors and cut off the boot on your network cable. Yeah. Actually, seriously, what can you do about it? Well, don't put admin interfaces on the internet. Has anyone heard this before? Here's a controversial one for you. Support legislation for mandatory vendor-controlled patching. Okay? When I talked about asymmetric capabilities, we have a huge problem, because we have, this is just one class of device, just one type of operating system on one vendor, and we've got tens and tens of thousands of compromised machines. And the telcos that operate them, that own these machines, don't care about them. Cisco doesn't care about them. They only care about what new stuff you're going to buy next quarter. And so we need legislation to force them to patch this stuff. And sure, enterprises want to opt out of that. That's fine. If you've got a security team and you want to manage it yourself, fine. But we need to change something. This can't continue. We could notify the organizations. You might say, yeah, just reach out to those organizations, James. I've done my part. I've told a bunch of people, and when there's CERT team to talk to, then I'll do that. But I mean, most of them, they've got no one to talk to, and they don't care. You could try and put pressure on Cisco. If anybody out there can just tell them to stop doing stupid things like enabling a web interface by default, that would be great. And actually, I mean, this is actually my cheeky sales pitch. You could block all node IPs at the firewall. You just have to find somebody who can provide you with a list of those IPs, So my conclusions. So state threat actors based in the PRC, and that's Mandiant's attribution, not mine. It's just the two jigsaw pieces fit together so well that I'm confident in making that link. They're using market-driven competitive services ecosystem. They're using DevOps approaches to managing like 40,000 node network. They're also using the Tor network, but why wouldn't they? They're using commercial VPS hosting systems. If anybody works in CTI recently, any of these Chinese espionage campaigns, if you get IOCs and you go and look what they actually are, then they're just crappy Linux boxes hosted somewhere, usually in the Netherlands or in India or in Indonesia. There's all these little hosting companies, and that's what they're using. And they're using our own critical network infrastructure, all of those routers, to hack our governments and other sensitive targets. They're doing it in front of our eyes, and literally no one cares. But hopefully you do now. Thank you.
Thank you very much, James. We have time for some questions. Who have some questions? Yep. Hello?
Yeah, you can talk. Can you explain what influenced your ethical scanning standards?
Can you just repeat? Can I explain what, sorry?
What influenced you? Ethical scanning standards. So what influenced you to scan?
Okay, so the ethical scanning stuff, in fact, if you just go onto our, I changed the screen resolution here. Let me just go back to, it's not a link, I can't click on it. Okay, if you go to our website, ONYPHE.io, in the docs you'll find that. What influenced us is really, it's really scan slowly. I mean, I can just go through a number of them. So scan slowly, don't stress the target machines. Be really clear about what you're doing. Every one of our probes has got a web server running on port 80 saying, this is who we are, this is what we do, this is our opt-out process. If people want to opt out, it's no questions asked. So, some people say to us, oh, but then cyber criminals will just opt out. That's the way it is. We've got to be better than them, ethically as well as technically, right? So it's really about scanning slowly, being as clear as possible about what we do. And ONYPHE was founded in 2017. It's really Patrice thinking about this, talking. We also talked with, like ANSI, because they also are doing scans. They have a program for doing scans. So it's sharing ideas and coming up with a framework together over the years.
So you said about dynamically blocking the hour of IP, but if you do that, weren't you going to be like blocking customers to communicate with each other?
Sure, yeah, no, I should have said that. I mean, if you're doing business with, I would say if you're just doing business with other organizations in France, for example, if you can actually look at, well, who's got a compromised device in France. And it's, I don't recognize most of the names of the organizations, right? So there's a few universities, hopefully not anymore, but but basically it depends who you're doing business with. But it's the same with IOCs, right? I mean, a lot of vendors will say, okay, use IOCs to block the firewall, but if you've got a malicious IP on Amazon, or on a random hosting company, next week it might be a legitimate service. So it's the same problem. Yeah. Okay. Is that okay? Yeah, at the back.
I have a question regarding the ORB2. What strategies and technologies are being developed to effectively detect and mitigate the activities within sophisticated proxy networks?
The orb networks?
Yes.
Yeah, I mean, so the orb networks, this is really just a new vocabulary to talk about the way threat actors are operating. So in the past we talk, you'd have your diamond diagram and you'd have threat actor infrastructure and you'd have a list of domain names, IPs and whatever. The problem is that if they're using an orb network, then you can't associate those IPs with one threat actor anymore. Attribution's impossible. So the point of this talking about orb networks is really to just give a name to this new way that threat actors are working. And these terms like relay node, traversal node, exit node, Mandiant is trying to push those, and so am I now, so that you can say, well, maybe we can get a list of the exit nodes and we can block those. My router's compromised. It's a traversal node in an orb network. There's no way of, my talk was about the fact that we can't really do anything about the rest of the devices because they belong to people who don't care. So. Sorry, that's a crappy answer, but...
Other questions? Nope. Do you have a question? Yeah? No? Okay. Well, no. Keep your applause for after.
So in the Netherlands, we have something called the DIVD, which sends message to companies who are vulnerable for something. Maybe you can do the same?
So we have currently, we do weekly scans for the vulnerabilities. We have several million only critical vulnerabilities. We only scan for vulnerabilities that are on the Caesar Kev list or actively exploited, or we have some other, and we have several million every week. So the problem is that we would only do that. And I don't know if I tried to report some of these compromised routers to organizations in a genuinely, I want to be helpful, I'm going to save the internet kind of way. Have you seen their forms? I would spend half an hour on one organization just trying to say them, this IP is pwned, right? That's when I want to tell them, but they're asking me to prove step by step that my finding is, because they have these vulnerability disclosure programs and the form is made for a vulnerability in their app, on their iOS app. And I'm like, no, it's your Cisco router that's screwed, but it's just impossible. And we have a business to run. So, but if anybody else wants to help, then, please talk to me. Yeah.
Thank you, James, for your talk. I have a question. Do you have some information regarding the orb network? Does the communication between the nodes are encrypted or are they in the clear? And how does the threat actor providing the network to other threat actor, are they, let's say, spying each other on them?
So I just point you towards this article. I have exchanged a couple of messages with the author, but everything that I know is basically in this article. So they're using the relay nodes to actually manage all the other nodes. I think that's why the first command was OSPF nearest neighbors. They want a topology, so they know that, well, these 3 boxes are behind this box. So when I want to patch those 3 boxes, I'll send a command to this one, and this one will patch the 3 behind it. So I think from reading the article from memory, at the very least, they're using TLS. Yeah, but it's not in the clear. So at least Mandiant are, but of course Cisco and a bunch of other organizations are also trying to understand this, but it's quite new. So I'm sure at some point over the coming months we'll get more information.
Thank you. Another question. We do have available the list of Tor exit node IP addresses. if someone want to block them or do whatever with them. Do we have some kind such list for the exit node of the ORB network available, or is it something not available?
Well, I mean, no. What we have, I'm just answering the question. It's a commercial service. We can sell the list of IP addresses that are compromised in this network, but it's changing all the time, and that's what the threat actor wants. So on a weekly basis, you would have to basically refresh that list. I mean, it's not so dynamic that it's not half the list changing every week, but there's a few percent changing every week. So. And like I say, it's new. This blog article, the concept of ORB networks, was coined by Mandiant earlier in February this year, and this is the first article about it just 6 weeks ago or something. So.
Do we have another question? No? Well, James, thank you very much.
Thank you.
And. So, it's a pleasure to offer you the bottle of champagne from our partner EPIOS.
Wow, class. Thank you.
So, if you liked James' talks, he will give a workshop tomorrow also. What about your workshop? Maybe you can do in a nutshell?
Yeah, so the workshop is attack surface discovery using OSINT. It's not really using ONYPHE. It's using all the other tools, but what I'm bringing is a process, like a standard process you can use using open source tools to do an attack surface discovery, either for blue teaming or red teaming. So hopefully that will be helpful for some people.